Okay, so we're going to do an introduction to Python, but it's not really an introduction to programming. This talk assumes you know what if-then-else statements are, and assumes you know what arrays are, assumes you know what loops are. So if you know those from another programming language, that's great, or if you've taken some kind of logic course and you've covered those topics in your logic course, that's great too. Okay. So every time you learn a new programming language, the first program you ever write is a program that prints out the phrase "Hello World." So for example, if you know Java, you would know that in Java, to print out the phrase "Hello World," everything in Java is encapsulated inside a class. Okay, so we have to create a class, give it a name like "Hello World," for example. And then this is kind of a leftover from the programming language C and C++, that out of all the functions in your program, the one that initially gets control when your code runs is the one called main. So in Java, they wanted main to be a void function, meaning it returns nothing. In C and C++, it actually returns a number, and the number tells you whether or not the program ran successfully or what went wrong when it was running. The function is static, meaning there's only one function for the entire class. If you were to start to instantiate this class, there would only be one function for it. Static means it's a class function, not a instance function. It's public, so it's accessible to the outside world. And then when you want to print something, you have to go into the system library and go into the out class, and inside the out class there's a static method called printLine. So you're calling the printLine static function of a class that came from the system library, and that would allow you to then print "Hello World." So if you have no idea what object-oriented programming is, and you don't know what classes are, and you don't know, you're new to programming, you have to do a lot of stuff that you do not understand just to print out the phrase "Hello World." To do the same thing in Python, you say print "Hello World" in parens, and that's it. So that's kind of the idea behind Python. So Python, well, let me just go over the different types that there are in Python. Python gives you primitive types. So when a programming language gives you primitive types are the types of storage that you can use, the programming language provides you, that you can use. You don't have to define it. It's not user-defined. It's not defined by you. It's defined by the programming language. So, so the primitive types, I don't know if you're going to be able to see this. This says primitive, right? So these are data types in Python. There's primitive types and non-primitive types. So when you download the slides, you'll be able to see these. Okay, so the primitive types are integer, string, boolean, and float. Integers are numbers that do not have decimal points to them. Floats are numbers that do have decimal points to them. Booleans are variables that are either true or false, the only value they can have. And strings are collections of characters, really an array of characters. Okay, so for example, in many programming languages, before you use a variable, if you're going to say radius equals 5, you might have to declare the type of storage that it is. You might have to say it's an integer or a string or a float before you use it. In Python, you do not have to declare the type of the storage. You can just say radius equals 5, and Python will create an integer for you. They will assume it's an integer because you don't give a decimal point, so it assumes it's an integer. You could say pi equals 3.14, and it'll create a floating point number for you. You could say message equals double quote. The area is colon double quote. That's a string of characters. So Python will automatically assume you're trying to say, make a variable that is of type string. You could say, it is raining. So that statement is either true or false, right? Like today it's sunny. But it is raining equals true. you could assign that, it'll make a variable called it is raining, and it'll make it a Boolean, because you assigned it to either true or false. Okay. The non-primitive types, which will come up, well, we'll talk about arrays today, but we'll talk about non-primitive types like lists, arrays, files, tuples, and sets, which makes Python a very interesting language in that they give you this in the language and a lot of functionality. We'll go over some stuff in arrays just to show you where this other stuff could lead to. We'll go over arrays today. Okay. So what is Python used for? Well, it's used for web development, server-side development, software development in general, a lot of mathematics, very popular in mathematics and data science, and also for system scripting. So scripting is popular, and a good language for scripting would be like PHP or Perl. In other words, where you can type up code very, very quickly. You don't have to declare everything as integers and spell everything out. If you have ideas in your head, you can type it up very quickly and test it out. So type in a little script. So it's good for those, good for those type situations. Mathematics, you're going to care about speed. So usually a language that is good for scripting is bad on speed. And languages that are good for mathematics are very fast, but very cumbersome to write code. This happens to have a nice cross-section of both. So what can Python do? So I guess you could read through these, but it can be used on the server to create web applications. So a server is like, you connect to Twitter. Twitter's the server, you are the client. So you could code in Python on the server side. Python can be used alongside with software to create workflows. Can be used to connect to databases simply. That's also a server-side application. And can read and write, read and modify files very easily. Okay. It could also go through big chunks of data, performing operations on them, like statistical operations, what's the median, how to sort the data, and things that come up in data science. So like when you log into a web page, like Amazon.com, and you throw something in your shopping cart, all of a sudden you see at the bottom of the page, people who buy, toothpaste also buy toothbrushes. And how do they know that? Well, they go through large sets of data of all the things that people are buying and putting in their cart, and they notice that there's a pattern. When someone buys toothpaste, they also buy a toothbrush. So then they can start making recommendations to you. So that's a field called data science or machine learning, and Python's a very good language for that too. Okay. So why Python? So these ones, you could kind of read through these when you get to the slide. There's no point in me reading these slides to you. You could read through these. So these are good things for us to know, starting out in Python, and then advantages of Python over other programming languages. So you get a chance, go through, read through these, and okay. So let's just look at a few things that we know from other programming languages or just from our logic class. Suppose we had, okay, so an if statement. In many programming languages, if we said if, what comes after an if statement is always a Boolean expression, an expression that could either be true or false. So the reason why we have if statements is we have code that we want to run sometimes, not all the time. If it runs all the time, we just write the line of code and it runs in our program. But sometimes we want this line of code to run and sometimes we don't. So what times do we want it to run? When the Boolean expression is true. When do we want it not to run? When the Boolean expression is false. So let's say Mets and Phillies, I choose Mets and Phillies because we're like halfway between New York and Philadelphia. So pick a couple of local teams. So suppose the Mets score, this is an integer, and it contains how many runs the Mets have. If the Mets is greater than the Phillies, then we're going to print the Mets are winning. Okay. So in many programming languages, you could say if, sometimes they require braces around the Boolean expression, sometimes they don't. Python doesn't require it, it just has you type out the Boolean expression, then have a semicolon. The code that runs if the statement is true is all of the lines of code that are below the if statement that are indented. So Python uses indenting. How far do you have to indent? There's no official rule like you must indent 4 spaces or anything like that. But there is an official rule, you must indent the same amount. If you have multiple lines of code, they must be indented the same. So you can't have like some variable indentations. So pick an amount you want to indent and then stick with it. So, okay, so indent is required for an if statement. You cannot say if Matt's greater than Philly, colon, and then have the next line of code right below it. You can put in the word pass, we'll talk about that a little bit later on. I mean, don't do anything. But you have to have, the next line has to be indented or you're gonna get an error. Okay. So now, for example, if you said if the Mets are greater than the Phillies, semicolon, and then you did not indent and you said print the Mets are winning, you might think that this will just print the Mets are winning no matter who's winning. But actually, you're going to get an error because you did not indent after the if statement. Okay. And then we have the if-else. Some people call it the if-then-else. Can't have it else without it then. So sometimes it's called the if-else statement, sometimes it's called the if-then-else statement. So what we could do is we could say if the Mets is greater than, the Mets score is greater than the Phillies score, then we indent and we say Mets are winning. Else, colon, not semicolon, full colon, print the Phillies are winning. Okay? So this will, if the Mets have a higher score than the Phillies, we're going to say the Mets are winning. And if anything else is true, we're going to say the Phillies are winning. So there's a logic error here, right? If the game is tied, we're going to print out the Phillies are winning, and that's not right. Okay. So, now there could be many other cases, right? So these are baseball teams, so the game could be, it hasn't started yet, it's been rained out. There's a bunch of other results that the game could have. So you could have many, many situations. And one thing that is popular in programming languages, if you find that you have many, many scenarios. If today is Monday, do this. And if today is Tuesday, do this. And if today is Wednesday, do this. And you're going to be writing out rounds and rounds and rounds of if-then statements. And the day of the week can only be one of the days. It's very popular in programming languages to have what's called a switch statement. Just, out of all the possible cases, you could have many, many cases. Do a switch, have it jump to the one that's true and let that one run. So many programming languages have a switch statement, and that's typically used when you have many, many, many if-then statements in a row. Python does not believe that the switch statement is necessary because their syntax is so simple. If whatever your situation is, do this. If whatever your situation, so almost inherently Python, by its nature, by its simple nature, Python is like a switch statement. So they felt they didn't need it. Well, I kind of agree. All right. Okay. So arrays. What are arrays? If you don't know what arrays are, hit pause and then learn what arrays are. But what arrays basically are is when you have a collection of variables that have something in common with each other. It's sometimes advantageous, instead of making up an individual variable name for every variable, to have them grouped together under one name and then only have them separated by an index. So for example, if we had 3 local baseball teams, the Mets, the Yankees, and the Phillies, and rather than make a variable for the Mets and another variable for the Yankees and another variable for the Phillies, and then you have to remember, like if you call it team 1 equals Mets and team 2 equals Phillies, you have to remember what variable is what. So it might be a good idea to have a variable called teams, which is going to actually collect a set of teams. And then each one is only separated by a number. This is teams 0. We're going to start with 0 in computer science. Most programming languages start with 0. Team 0, team 1, team 2. So we have a collection of variables with the same name is called an array. So we have an array called teams. Team 0 is the Mets, team 1 is the Yankees, team 2 is the Phillies. So, oh, by the way you do comments in Python is with a pound sign. Everything after a pound sign to the end of the line is considered a comment. It's code that doesn't run, it's just there for you, so in case you go back, you're like, why did I write this code 2 years ago? Oh, that's why, these are local teams. Okay, like in many programming languages, there's a function len or length that you could call you could say len on teams and it'll tell you how many teams are in the array. So this will set n to the length of the array, which in this case is 3. There's 3 teams. So now what we can do, we now have a variable that's equal to 3, so this would be an integer, n would be an integer. And then here's a comment, we can index starting at 0. We go through the array starting at 0 and we go all the way up to n minus 1. So team 0 is the Mets and team 1 is the Yankees, right? So team 0, team 1, team 2. Now, so this is kind of a bonus. Arrays in other programming languages don't have these functions. They're usually add-ons. In C++, they have the standard template library. In Java, they have generics that you could add on to it. And then you have a data structure like an array, which has language-supplied functions. These come with Python. So for example, if you have an array called teams, and you have the Mets, the Yankees, and the Phillies, you can say teams dot remove, and we're going to have a whole lecture on Python arrays, all the things you can do with arrays, but I just want to go over one or 2 examples now, just to get an idea of what's available to us. We could say take the teams arrays, call remove, and remove the Yankees. So this will remove team 1 from the list. And what this does, it does a lot of work for you, so this is something you really got to appreciate. If you had an array with 3 teams in it, and you wanted to remove the Yankees, you can't just delete this one and have the Mets be team 0, and the Phillies be team 2, and team 1 is now blank. What you would need to do is remove the Yankees, move the Phillies over to slot number 1, and then get rid of slot number 2. Resize the array now to be a 2-element array. So this function actually does a lot of work for you, and all you have to do is type remove. It does all the work for you. If you want to slap a team onto the end, append to the end of the teams array, you can just say append Orioles. That's Baltimore's kind of close, around about 3 hours away. So we get rid of the Yankees and we add the Orioles, right? So it'll create a element on the end of the array. So what it's really doing is it's creating a brand new array which has room for one more element, copies the whole array over for you, and then sticks in the last element. So these functions are great. So these are all the functions. Like I say, there's so much you can do with arrays, and one of the things that makes Python such a great language is using one-dimensional and two-dimensional arrays and all the operations that you could do very, very simply just by calling the supplied functions to it. So just want to very quickly let you know which ones they have. They have the append, which we just talked about, clear the array, copy the array, count the array. So it tells you how, it returns the number of elements with a specific value. So you could say, count how many teams are named Yankees, and it'll come back with 1 or 0. You could use count, and if it comes back with a 1, it's kind of like you're using doing a search onto it. You could do extend, index, telling me the number of the thing I'm looking for, inserting something into the array. So you could say take the Yankees and put them in position 3 into the array. It'll make room in the array, for make room in the array at the spot you want to put in. You could do a pop of an array, so you can actually remove an element from a specific position. So you could say remove team number 2, and then it'll remove it. Or you could say remove, and it'll remove the first element that has the value that you put in. So for some reason, if you had 4 teams named the Yankees, and you said remove the Yankees, it'll only remove the first one. You could reverse the order of the array, you could sort the array, put them in sorted order. So these are great functions that in other programming languages, you'd have to code these up yourself. So these are great functions for us to know about. Okay, so let's look at for loops. So for example, in Python, we can have a for loop. Here's comment Python, right? So assuming we had the array from before, let's say the original array. What was it? The Mets, Yankees, what was it again? Mets, Yankees, Phillies, okay? Suppose I wanted to print out every element in the array. In Python, they have a for loop. This syntax is a little unusual if you're accustomed to, C++ or Java. In Python, you could say for, give a variable. Variable could be an integer, float. You don't have to declare the type. For x in teams, print x. It'll print out all the teams. So that would print out the Mets, the Yankees, and the Phillies. Print out all the teams. That's great. If you wanted to do the same thing in Java or C++, right? Would this work exactly in C++? I think with C++ would work too. But if you wanted to do the same thing in Java, you would have to do this. You would have to create an integer variable, let's give it a name like n, and ask what is the length, we would call the length function, on teams. It would tell us the array is of size 3. Then we'd have to create a for loop. The for loop, we have to declare a variable. It's popularly used the letter I to mean iterating, because you're iterating through the array. We create an integer called I, and we initialize it to 0, because we want to start with team 0. Okay? We then have a Boolean expression. As long as I is less than or equal to n minus 1, as long as we haven't gone past team number 2, so we're iterating through the array of size 3. We're going to go from 0, no more than 2. So we're going to visit team 0, team 1, and team 2, and then we're going to stop the loop. So as long as this Boolean expression is true, we're going to do whatever happens here. And then we're going to do I equals I plus 1. Then what are we going to do every time we go through this loop? We're going to print teams I. So we're going to go into the array of teams and print each of the teams. So by being able to just type this up real quick, this is a big headache saver. You could just say, print out all the teams, right? Don't make me fiddle around with how big is it, and how many elements are in the array, and then go from 0 to n minus 1, and if I equals I plus 1, if I make a coding error, I'm going to print out bad results. This is great. I could just say for i's in the set of teams, just iterate through the teams and print them out. So that's a great great thing that Python does. Okay. Now the other thing that it's doing for you, like I say, Python is majority is dynamically typed language. So when you use a variable, at the time you're using it, the runtime environment is looking at what you're using it for and going, oh, I think this is a floating point number. I think what she's trying to do is put a string into here, so I'm going to make a string variable. In general, that slows things down because every time you run the code, it has to anticipate what you're doing with it. And then based on what you're doing with it, it allocates enough space, and the space has to match the type. So generally this makes things slower, but great for scripting. Great for just typing up some quick code to try something out. So in this case, I'm saying for C, I'm using the letter C because that's the first letter of a character. That means like one letter inside of a string. So I'm doing a for loop now. I'm saying for C, the character, in, and I have in quotes a string, and I'm just saying Yankees, right? So it's the string Yankees. So what am I going to do? I'm going to iterate through this structure. What is this structure? It's a string. What is a string? a collection of an array of characters, right? So basically going through this array of characters. And so the value of C will equal capital Y the first time through. And I'm going to print the character. So it'll print a capital Y. And then it's going to print it, C is going to become A, and it's going to print A. So basically the variable C, which the runtime environment understands it's a character, a string of one letter, it's going to take on each one of these values and print it out. So this will print out, this code, this for loop would print out Yankees. Okay? Now, if you're familiar with, hopefully you're familiar with loops that have breaks and continues in them. So we can now say for C, the character is in the string Yankees. So one thing I could do is I could say, now I'm indenting again, right? So it's an indented-based language, Python. So in the for loop needs to be, the code needs to be indented. I could say if the character is equal to the letter E, then break. That means get out of the loop. The loop ends. So character C is going through each of the letters, capital Y, A, N, K, E, E, S. So it's going to print Y, it's going to run through the loop again, become an A, print an A, run through the loop again, become N is not an E, prints N, goes to K is not an E, prints a K, comes back up, it becomes the first E, and the first time it becomes an E, we break out of the loop and we're done. So this code would print Yank. Okay? So the idea in loops is, there's a whole big debate on whether programming languages should use breaks and continues because it makes it hard to debug problems. But Python decided to allow breaks and continues in their code. Okay, so this code would print Yank and stop. As soon as it hit the first E, boom, the for loop's done. Continue is a strange word, I believe, because it's basically saying we should continue running through the for loop, but we should skip everything after the word continue. So it might have been better, instead of using continue, it might have been better to call it skip to next loop, something like that. Instead of putting the word continue here, it should say go to the next step in the loop, something like that. All right. So it's kind of like you're breaking out to the bottom of the loop, but then you're going back up to the top and continuing. All right. So anyway, we can have code that says for C is in the string Yankees, if the character we're looking at is the letter E, then go to the bottom, jump around this print and go to the bottom of the loop and then come back up to the top. So this would print out Y, A, N, K. When it equal to E, it won't print. It'll just go to the end of the loop, skip over this print, go back up to the top, it'll equal the next E. It'll skip again the print, and then it'll become S, and that will be printed. So this code would print Yanks, Y-A-N-K-S, no E, which is what the Yankees nickname is, right? So that's, put that in a function called nickname. Okay, all right, so, okay, and then for loops with ranges on them. Okay, so sometimes this is, again, this is just for speed. So in Python, we could say for x in, and then just give it a range. So you know, like in Java or C or C++, you'd say for I equals, you have to explicitly say the first value, and then you have to have a Boolean expression, and then you have to increment, right? The Boolean expression usually is the upper bound on where, on what makes the loop stop. So this is one just thing that eats at me about the way they design Python is this. If you say for x in the range from 2 to 6, print x. What it'll effectively do is create a variable called x, which is going to be an integer, right? Because you're starting at 2 and you're ending at 6. And it will print x, provided that, I'm sure I like this, x is is 2 or more and less than 6. So you might think, intuitively, I would think this would print 2 to 6, but it doesn't. It prints 2 to 5. So it would be the Java or C++ equivalent would be like this. For x equals 2, as long as x is less than, not less than or equal to, less than 6, x equals x plus 1, print x. So we'll print 1, 2, 3, 4, 5, and not 6. So you gotta remember, starting at 2, going all the way up to 6, but not including 6. It would print this loop. So that one, for some reason, that one annoys me, that it doesn't include 6. So what it's doing for you is, this is what's great about Python. You don't have to work out the logistics yourself. It's just starting at this number and doing every number as long as it is less than this number, not less than or equal to. And I think less than or equal to is intuitive. Maybe I shouldn't say that because it'll confuse you. Okay, all right. Then, okay, so now there's no rule that says for loops must go from, for loops don't have to necessarily go from a low number up to a high number in increments of 1. That's usually what happens, but not always what happens. So if you wanted to, you could say go from starting at 2 and go all the way up to 6, but not including 6, and increment by 2. You could do that. And the Java equivalent would that be, it would be starting at 2, and as long as x is less than 6, not less than or equal to 6, x equals x plus 2. So now you're doing every other number. And you could go backwards, you could put a negative number, like if you wanted to, we had an assignment where we printed out the lyrics to 99 bottles of beer on the wall using a for loop. So we had a for loop where we went from 99 backwards down to 2, right? So, then you could make your this third number, which is optional, is how much you increment. Usually, you're running through an array. So 9 times out of 10, you don't need this, right? 9 times out of 10, you're going from 2 to 6, incrementing by 1 each time. But if for some reason you want to increment by some different number, you want to count backwards or whatever your application is doing, you have that option. You have a third number, and that's what you'll increment by. And it could be positive, it could be negative, it's up to you. Okay. All right. This is another thing that's very cool. You can just make a random set of numbers. So suppose you wanted to print out a list of all the months that have 31 days in them. And you know them in your head. You would just like to print them out, in a for loop, print out some really long message. So you could just say for M, first letter of the word month, for M in 1, 3, 5, 7, 8, 10, and 12. Is that right? 10? 10 is October. That's 31 days, right? Okay. So now you could print out, it'll say each one of these has 31 days in it. So you could come up with an array with numbers off the top of your head, write them out, and then print out messages that'll list out each one of the months that it has that many days in it. So really cool stuff you can do with loops and arrays. And like I say, we'll go over Python. There's a lot of very, very cool programs you could run using data in arrays to draw conclusions like, people who buy toothpaste also buy toothbrushes, that kind of stuff. Okay. All right, and then also you can't talk about loops without talking about the while loop, which we went up, when we talked about loops, for loops and while loops, we realized that anything you could do with a for loop, you could do with a while loop, anything you could do with a while loop, you could do with a for loop, except that while loops give you a little bit more freedom, because in a for loop, you're given space to initialize, and you get one line of code to initialize, one Boolean expression, while loops have one Boolean expression, and then in a for loop, you get one line to do your incrementing. Whereas with a while loop, you have a lot more freedom. So, for example, in this while loop, I'm basically starting off I with a value of 1, and I'm saying as long as it's less than 6, print I, and then this is their shorthand for I equals I plus 1. So in this case, I'm printing everything from 1 to 5, right? Oh, I should have made it 2, just to have it match the previous example. Okay, all right. So, so in this case, so the reason I'm saying, you know, a lot of people will argue that you could do anything with a for loop, you could do it with a while loop, anything with a while loop, you could do with a for loop. But a while loop gives you a little more freedom because this is my one line of initialization. I can actually do more stuff if there is more stuff that needs to be done. Because you actually do all your initialization before the while loop starts. The Boolean expression is the same, and a while loop only has a Boolean expression, whereas a for loop has an initializer, a Boolean expression, and an incrementer. And then in your while loop, you're required to write the increment step in the loop. If for some reason you have some complicated incrementing, if this increment by 1 and if that increment by 2, you can't jam that code into a for loop. You have to express it in multiple lines here. So like I say, for loops and while loops can be interchanged into each other unless you have a very complicated incrementing. You really have no choice but to use a while loop. Okay. And then in this case, we have, in this while loop, we're starting off, we're initializing I to be equal to 0. We're saying while I is less than 6, colon, indent. So everything indented happens on a run of the loop. We can print the variable, add 1 to it, and then we throw in this extra step. If the variable is equal to 3, we're done. So what would this actually print out? Well, I would start at 1. We would print I. We would make an I equal to 2. We'd ask, is it equal to 3? No, it's not. The Boolean expression here is false, so the break gets skipped. We come up to the top. I is now 2. We would print a 2. We'd turn it into a 3. Ask, is it 3? And if so, boom, we're done. So this code would print 1 and 2, and then it would be done. And what's going on here? Continue instead of break. Same thing, so this would print a 1. This would print a 1. It would print 1, become a 2. We'd ask, is it 3? No, it's not 3. So we would this line of code doesn't do anything. Because when it's false, we go to the top of the loop, and when it's true, we skip everything after it, there's nothing after it. So this is kind of a trick question. What does this code do? It does nothing. Actually, any continue with no code after it accomplishes nothing. So that's a trick question. So you go to a job interview with Google, and they might ask something stupid like that. So, all right, so that's up to you.